Hi, my name is YongJin and my partner is Darren. Our objective is to investigate the Taylor series for cosine half x about x equals pi. So we are given the Taylor series for function fx. So fx equals to cosine half x, and f prime x when differentiated becomes negative half sine half x, and f prime double prime x equals to negative 1/4 cosine half x, and f triple prime x equals to 1/8 sine half x. So when you sub in pi to our fx, we get 0, and f prime pi equals to negative half, f prime double prime pi equals to 0, f triple prime pi equals to 1/8. So using the Taylor series, cosine half x equals to negative half bracket x minus pi plus 0 plus x minus pi to a power of 3 over 48. So you can reduce the term furthermore to minus x over 2 plus pi over 2 plus bracket x minus pi to a power of 3 over 48. So based on the website, when you key in the functions, you can conclude that the graphs do not look the same, and they only roughly look the same at about x equals to 1.5 to x equals 4.5. So the way to make the graphs look more similar is to add more terms to the Taylor series.
With reference to Taylor's series formula, the function cosine half x is represented by a power series in x minus pi, with more terms added in, which is called the Taylor series. We then typed in the new Taylor series in row 3 in Desmos's website to draw the graph. In comparison with the old graph, the new graph looks more similar to the graph of y equals cosine half x, as they look the same from -2 to 7.5. Therefore, we can conclude that the approximation of a function using Taylor's series is not entirely accurate, as it is just an estimation. At x equals pi, the function cosine half x is equals to 0, and 0 is within the range where the old graph, new graph, and the graph of y equals cosine half x are similar.